Welcome to you all. Hope that this session will give you more understanding about Program Evaluation Review Technique, PERT, with a relevant basic example in project network analysis. This video is therefore a continuation of previous videos as a part of the network analysis. Hence, it covers initially an example question with its subsections from A to E, and then their relative potential answers. The main objective of this video is to make you understand the preliminary application of Program Evaluation Review Technique, known as PERT, in network analysis. In this context, the way of determining the durations of activities as required to determine a project duration with their probability concerned is presented. Accordingly, an example is presented here with information about a project and the potential questions to be relatively answered based on the information available. Here, an example is given for a project with its relevant activities, their respective precedes, and 3 possible completion durations in a project in a table. In the table, first column represents the activities of the project, and the second column has their respective preceding activity or activities. The rest of the columns have information of 3 types of completion durations for every activity. They are optimistic duration, known as A, most probable duration, known as M, and pessimistic duration, known as B. Also note that all durations are given in months. In this section, the following subsections of the questions are relatively presented to answer with the information given in the table. A. Determine the average, mean, duration, standard deviation and variance of each activity. B. Set up a new table with preceding activities, mean duration, standard deviation and variance for every activity of the project. C. Draw the project network diagram. D. Determine the mean completion duration of the project. E. Assuming project completion duration form the normal distribution, determine the probability of completing the project in 30 days. Question A. Determine the average, mean, duration, standard deviation and variance of each activity. Answer A. To determine the mean duration, standard deviation and variance of the activities, relevant formulas need to be applied here. The formula to determine the mean duration of activity A, known as TA, is given here. It is equal to the sum of optimistic duration, A, plus 4 times of most probable duration, M, plus pessimistic duration, B, divided by 6. As activity A has the 3 durations as 7, 10, and 13, respectively, possible estimate of the duration of activity A, known as TA, equal to the sum of 7 plus 4 times of 10 plus 13, divided by 6, that results in TA equals 10 months. Similarly, the standard deviation of activity A, known as sigma A, equals to the difference between pessimistic duration, B, and optimistic duration, A, divided by 6. As activity A has pessimistic duration, B, 13 months, optimistic duration, A, 7 months, and their difference 13 minus 7 equals 6. Hence, the standard deviation of activity A equals to dividing the difference 6 from 13 minus 7, by the constant value 6 in the formula that results in 1. As the variance is the squared value of standard deviation and the standard deviation of activity A is determined as 1, the variance of activity A is squared of standard deviation 1, thus resulting variance activity A, known as sigma A squad, equals 1. In the similar way, all these 3 measures, mean duration, standard deviation and variance for activity B, are determined and shown here. You may also calculate and check the answer presented here. Using the respective formulas, the required calculations for all other activities should be determined respectively in the similar. In this context, for all the activities of the project, from A to H, all relevant measures are presented in a table as results for your reference and convenience. You may work out and check your answers here. Question B. Set up a new table with preceding activities, mean duration, standard deviation and variance for every activity of the project. Answer B. For this question, you have to reproduce the table in the answer 4A, with an additional column next to the activity column. The additional column can represent the preceding activity or activities of each of the activity in the project. The new table consisting of activities of the project, and their respective preceding activity or activities, mean duration, standard deviation, and variance are given in a new reformulated table. Question C. Draw the project network diagram. Answer C. To draw a network of the project, two aspects should be in consideration. Firstly, how do you represent an activity and an event in the network diagram? In this case, the network diagram of the project has been presented with activity on arrow format. Secondly, how can the combination of activities and an event be presented? The format of combining the activities, R and S, and an event, indexed as X, shown here. Also, you can note that the event X has two additional measures of durations, earliest starting time, known as EST, and latest finishing time, known as LFT, that are useful in other lessons to come. For the time being, you may have them for knowledge and can skip them for the time being. Further explanations with respect to these durations would be given in the subsequent videos. Your valuable comments and feedbacks are expected here to produce other relevant videos, please. Based on these two specifications, the network diagram is drawn next. Accordingly, the network diagram of the project is presented here. You can see that there are activities from starting activity A to finishing activity H, with conditions of their sequential order and preceding activity or activities. In this context, the events labeled from 1 to 7 are presented to connect the activities concerned. To get to know the way of drawing a network diagram, you can watch the previous related videos. Question D. Determine the mean completion duration of the project. Answer D. You can find that there are three identical paths available to progress from event 1 to reach the final event 7 to complete the project. They are Path P1 consisting of activities A, C, F, and H, and its respective completion duration is available by adding their completion duration, 10 plus 9 plus 8 plus 5, that results in 32 months. Similarly, Path P2 has activities A, D, G, and H with the activity durations 10, 5, 10, and 5 months respectively. Their addition results in 30 months for completing Path P2. Now you may get to know in the similar way that Path P3 has activities B, E, G, and H and their respective durations, 11, 10, 10, and 5, result for having completion duration of 36 months for Path P3. Since Path P3 has the maximum completion duration, 36 months, this duration of 36 months is considered as the project completion duration. Question E. Assuming that project completion duration forms the normal distribution, determine the probability of completing the project in 30 days. Answer E. The determined mean completion duration of the project, μP, equals 36 months, and its respective probability is 50%, in accordance with the normal distribution perspective. The variance sigma p squared of mean completion duration of the project is the sum of the variance of the activities, B, E, G, and H, that constitute the project duration of 36 months. Hence, sigma p squared equals the sum of sigma b squared, plus sigma e squared, plus sigma g squared, plus sigma h squared. This indicates sigma p squared equals 0.44 plus 0.44 plus 2.78 plus 0.44 is equal to 4.1. Therefore, standard deviation of the project sigma p equals to square root of 4.1 that results in 2.02. In PERT, The duration of a project is also considered as consistent with normal distribution. This is applicable to the mean completion duration of the project, in this case 36 months. To determine the probability of completion duration between mean completion duration μ(p) and given proposed duration xp of a project as a whole, the standard normal deviate zp of the difference of the durations needs to be calculated with the formula for zp. Thus, the probability of specified proposed completion duration, here 30 months, can be determined by calculating the standard normal deviate z of the proposed duration and using the normal distribution table. As we know that the standard normal deviate z for the proposed duration xp is resultant of the difference between proposed completion duration xp and mean duration μp divided by the standard deviation sigma p of the project. In this case, proposed duration to complete the project xp equals 30, mean duration μp equals 36, and the standard deviation sigma p equals 2.02, thus resulting standard normal deviate z equals minus 2.96. As z equals minus 2.96, the probability of completing the project in 30 months can be the probability of x less than or equal to 30 equals z less than or equal to minus 2.96 equals 0.0015. As for x less than or equal to 30 and its respective z less than or equal to minus 2.96, the probability with a normal distribution curve can be shown as in the figure and next explanation in detail. Note that the probability for z equals minus 2.96 represents that the probability of completing the project between 30 and 36 months, and it can be derived from the normal distribution table 0.4985 for z equals minus 2.96. This is shown in the image on the left of μp equals 36, and the area 0.4985 of z equals minus 2.96. Also, you have to understand that the probability for completing the project in mean duration μp equals 36 months is 0.5000 on its left. Hence, the probability for the proposed duration xp less than or equal to 30 become a part of the probability 0.5000 for of μp less than or equal to 36. Therefore, the required probability is for xp less than or equal to 30, z less than or equal to minus 2.96. That is, probability of z less than or equal to minus 2.96 equals 0.5000 minus 0.4985 is equal to 0.0015. By multiplying this by 100, the probability of completing the project in 30 months is 0.15%. Thank you for watching this video. If you find this video is useful and or need more clarification, you may leave a comment about your thoughts. Your valuable comments can make me producing other related videos meaningfully with your support. Thank you in advance for your comments to be made.